welcome everyone to the Science Concert with Dr. Luke Lee. My name is Benjamin Lee, and I will be your session moderator for tonight's session. We welcome everyone here during these unusual times, but we're glad to be able to have this session for high school students and other members of KCA to be able to explore what kind of career paths or majors in college that you may want to go into. We'll just talk a little bit about how the session will go today. We'll start with an introduction and just explain how the webinar the tool will be used. Then Dr. Luke Lee will present his talk for the next 20 minutes. During that time, if you have questions, you may type it into the question window. But after that, we will have about 40 minutes to be able to do Q&A with the audience, either through your text questions, or you'll be given an opportunity to virtually raise your hand and be able to ask a question orally. Then we will have our closing poll just for 30 seconds to get some evaluation for the session. And then we'll just give you a heads up for the next science concert. So this is just a guideline for the attendees. So you notice that we're using the Zoom tool app, and currently you're in the attendee mode, and you're given a few options as an attendee to be able to interact. First of all, if you look at the top part of your portion, there's a drop-down menu where it says View Options. This will allow you to zoom the whole screen out to full screen or shrink it down, so you can adjust the size of your screen in that manner. Down at the bottom of your screen, there are 3 buttons. The first one is the chat button. So if you click on that, a chat window will pop up, and you can either do it as a pop-up or it'll be at a panel on the side. Here you can chat with just the panelists, or you can chat with all the other attendees as well. If you have a specific question that you would like to have it answered at the end of the talk, the third button where it says Q&A with the conversation bubbles, if you click that, these are the questions where you will type and we will go over them. I will ask Dr. Lee about these questions. And if you see a question that you didn't type but you want answered, you can upvote it by clicking the little thumbs up like button. Lastly, when we do the Q&A, we'd like to encourage you to ask oral questions, and that's where the middle button comes in. That's the raise hand icon. So during the Q&A session after the presentation, you can raise your hand and request for a mic. When you are selected as the next one to ask your oral question, you'll be notified through chat by the Zoom moderator. When your name is called, please unmute your microphone and ask a question. You'll be heard by everyone in this web session. And finally, at the end, please stick around to spend 1 minute to answer a questionnaire, and that should be it. The session should last a little bit more than an hour, so we hope you enjoy it. So now it is my pleasure to introduce our speaker tonight. He is Dr. Luke Lee. The world-renowned engineer and researcher Dr. Luke Lee is a professor of medicine at Harvard Medical School and at Brigham and Women's Hospital in Boston. His research areas are in bioengineering and nanobiology related to medical sensors and precision medicine. Prior to coming to Harvard, Dr. Lee was a professor at the biophysics program in the Department of Electrical Engineering and Computer Science at University of California, Berkeley, where he also received his PhD in applied physics and bioengineering. Prior to his graduate school, Dr. Lee was in industry working for tech companies for over a decade. So it's my pleasure now to introduce you to Dr. Lee. We can give him a round of applause. You can type it in the chat window. But Dr. Lee?
Thank you very much for your kind introduction. It is my pleasure and honor to share with you my life. So hopefully, even though it's a short time, I can entertain you, and you can feel free to ask any questions. So today, I'd like to start with my presentation. The title is To See a World in the Grain of the Sand for Healthy Life. I hope this message will convey you at this difficult time of the COVID-19 pandemic season. So I'd like to greet, because our group is known as BioPoets Group for the Healthy Life. We focusing on bio inspirations and then get new photonic device and optofluidics, electronics, technology, and science. As you can see, we are dealing with science and engineering. So hopefully you can get a good idea, even though you're a high school student, you can study, you can understand why you have to study many different science and as well as math and also humanity. So our mission is trying to create a new way of making medical device by having different convergence of different disciplines such as biology or chemistry or physics or biotechnology or even information technology. So we want to transform basic current health care system to make more innovative system. So we can think about collaborations and making new insightful idea from the nature, and then we get the new idea. So we want to basically write the poems. It's not a real poem, but it's a technical poem. You can design many different biochips, many different ways, but focus is a patient-oriented engineering medicine. So I want to really share with you a real poem. Why I'm introducing you. This poem is, it's amazing that late 1700, William Blake, he is amazing poet who predict what I'm trying to do late 1700. So he wrote many poems, but I just want to introduce these 4 lines, which summarize my research. He's asking us to see a world in the grain of sand and heaven in a wildflower and whole infinity in the palm of your hand and eternity in an hour. At this moment, it sounds very abstract, but I want to share with you each line, why he is talking about this and how I get inspiration. Next short video will explain to see a world in the grain of sand.
To see the world in a grain of sand. Is it possible to gaze at the health status of humanity and the earth in a grain of sand? Can we create smart sands to view DNA and RNA fingerprints from our blood and the earth in real time? Reflecting on Blake's poem in our fast-paced world provides an inspiration to find a proactive solution for our global biosecurity. The world is more dangerous today due to the emergence and spread of new infectious diseases. With smart sands, we can prevent such outbreaks from happening through early detection. We propose SANDS, Speedy, Analytical, Nano-Optofluidic Diagnostic Systems. Smart SANDs are on-chip for rapid and accurate molecular diagnostics. Smart SANDs can be used by anyone with a smartphone, even in areas where rapid and accurate diagnostics are usually inaccessible. Smart SANDs will be globally connected to an integrated data hub. Smart SAND's rapid and accurate molecular diagnostic network for human, agricultural, and environmental health will radically improve global healthcare and empower us to create a new, proactive, predictive, and preventative paradigm for enhancing global biosecurity. Is it possible to gaze at the health status of humanity and the earth in a grain of sand?
I hope you got the big picture. Why I'm,
To see.
oh, sorry. Oh, So now I hope you get an idea that how we can see world's health in the grain of the smart sand. Smart sand can really make impact. Unfortunately, at this moment, at this time of the COVID coronavirus pandemic, we need to have, but we didn't have this yet, but hopefully we can mass produce soon. So this uh, inspiration of the nature can also give us a nice photonic device that we can create. So I'd like to show you a bio-inspired photonics for smart sand. First, we can get inspiration from insect. So this is the two eyes, but within two eyes, there are many, many small lens. So called compound eyes of the insect. So insect eye has a lens, but there are underneath just like waveguides. So it's fascinating to see how nature already formed lens and waveguide itself so that they can see every direction. So using this kind of the nature inspiration, so we can make real artificial structure that can mimic similar to insect. So this kind of the insect eyes can be used for the future sensor as well as many different practical sensors that we can think about even for photonic PCR. I can talk about at the end. But here, this is one example. There's a smart sand using this insect eyes. So you can think about how to collect information as a smart endoscopy or environmental monitoring or remote monitoring and so on, so that you can think about biosecurity network, molecular level sensing network. And then in nanoscale, I want to also introduce you what is possible nanoscale smart sand to monitor emotion. Emotion means electronic motion in living cell. So this picture, I just want to share with you. I don't know how many people are interested in art, but this art by Vasily Kandinsky, he's a Russian painter, shown this interesting circle with a crescent shape. There are many, many circles, but this really inspired me to think about how to see cellular galaxy. This is, can you see many, many dots? This is nothing but nanoscale crescent, so that we can capture electronic motion inside of the living cell. So we deliver this inside of the cell using this kind of the structure. We can capture electron transfer motions in living cell. Also, using this kind of the crescent structure, nanoscale crescent structure, we can attach the DNA or RNA, a protein, and deliver inside of cell, and you can call from outside. Hey, cellular phone number 80 nanometer, can you dance with me? So then when you oscillate electron on the surface of this nanoplasmonic structure, nothing but this is a nanoparticle with gold structure, then you can release, attach the DNA or RNA or protein so that you can have a gene delivery. So you can also do sensing. After you deliver, you can also sense mRNA, or you can sense also oxidation reduction of the enzyme. So you can use this kind of the tiny little smart sensor inside of living cell to capture things that we didn't capture before. And then next line, he mentioned about heaven in the wildflower. You can see the beautiful flower, but we can see also there are symmetry in the flower. If you look at carefully, you will see symmetry. But then inside of also plant, there are also plant virus. You are worrying about right now coronavirus, but there's a plant virus you are eating all the time. The plant virus is not harmful, but there are also not only harmful, not harmful, but also the beautiful. It has a topology symmetry. Using this kind of the nanoscale structure, we are making green optical antenna. So you can harvest and you can capture this, and then you can coated with a metal layer so that you can use it as a sensor or gene delivery system. So you can use it as a both therapeutic as well as a diagnostic platform using this nanoscale sensor using plant virus. And then I want you to encourage you, if you study physics, this plant virus structure allows to generate different optical enhancement that you understand this kind of equation later, but I want you to encourage that all mathematics and physics is very important even for medicine. The last third line, hold infinity in the palm of your hand. In this case, I want to encourage you that it is our responsibility to take care of our earth, but then also it is your possibility to create many different innovative devices. In this case, we call soft state, a microfluidic device for many different biological analysis, single cell analysis or neuronal cell analysis or organ on a chip and so on. So we can create many interesting new devices for quantitative medicine. One example is instead of using petri dish, you have many thousands of the wells, so you can create so-called dynamic 3D cell culture chip. And then let me just briefly introduce you. Using this technology, you can make a mini brain. So mini brain, why mini brain? We want to mimic the the brain's structure using this device. And then we can also detect EEG. So we can form a repeatable formation of the mini brain. And then we can measure normal case as well as drug treated or LPS, which is actually from the pathogen. This LPS from pathogen can disturb our brain, and then you can see abnormal behavior of the brain can be monitored within this system, as well as screening the drug using this system so that we can find what is the best drug to fight back to the attack of the virus. And then the next one is integrated molecular diagnostic systems. It is relevant to current coronavirus defense, but we want to make sample to answer device at low cost. Basically, we are shrinking the laboratory inside of the hospital. So this chip allowed to drop the blood and then we can separate, and then basically we can do DNA and RNA and then protein detection simultaneously. So this is in the new design. I'll show you how this device, simple device, self-power integrated microfluidic point of care, low cost enabling molecular diagnostic system can be integrated. Here we already integrated all the reagents and then everything is processed. So this movie shows that sample can be digitized. There is no external pump. We build a vacuum battery here so that all those our biological sample can be isolated from each chamber, so that each chamber can be, each small dot is like the reaction chamber for the DNA amplification. So this showing you animation of how plasma is separated. Blood cell is moving forward, but plasma is basically separated in the chamber so that we can isolate them. This is the bad design I want to show you, but the proper design allowed to separate each chamber to be independent, so that each chamber, each circle is basically showing the blood plasma. All the cell is separated, so that at the end, each small dot, which is reaction chamber for the nucleic acid, DNA amplification of the disease can be detected. So last one, it's not the least one, but I want to share with you that he even predicted our work on this, an eternity in an hour. My daughter happened to have some disease when she was young, but I remember that doctor cannot really identify what kind of infection she has. So she was getting a lot of antibiotic without knowing what kind of specific infection she had. So many cases, thankfully she's alive, but many cases, our life can be really, I mean, fragile that people can die in an hour. Of course, we can die in the street, in the, by car accident, but think about how to speed up the detection. So we are making ultra-fast photonic PCR that allow to speed up basically the so-called DNA amplification detection using the quantum heat engine that you will study in the future, but basically using photonic PCR. Instead of using conventional PCR take 1 hour, we can do PCR less than 2 minutes. Now our record is less than a minute, and so on, so that we can think about how to make a very, very fast and precise smart sense. So eventually we can monitor not only our disease, but also water condition, as well as the food and agricultural product and so on, so that we can have a clear idea how to put them together. And last, I want to just share with you that it is important to see the picture, but then we have to think about one picture worth 1,000 words. There are many, many studies that you develop, but then one picture worth 1,000 words. But the more important thing is single understanding is worth 1,000 pictures. But I like to emphasize that one single action is worth 1,000 understanding. So we have to really think about what you do with this, what we study. So this is a similar kind of philosophy, but Goethe mentioned that knowing is not enough, we must apply. Willing is not enough, we must do. In the realm of ideas, everything depends on enthusiasm. In the real world, all rest on perseverance. Thanks for your attention.
Thank you, Dr. Lee. That was an incredible presentation. We have some questions here. So the first question is from Daniel Park, and he asked, what are nanoscales?
Nanoscale means we're dealing with roughly around 100, less than 100 nanometer.
Okay, and are these, I guess there's a follow-up question of, are these nanoscales going to be captured inside the cells, I guess related to the level of cells?
Oh, I see. Cell is 10 micron or 20 micron size, and our virus is around 100 nanometer. So if imagine that all those the crescent structure that I developed is a scale of similar to virus structure, or even the plant virus that we use is a similar size as animal virus, so that we can think about how to create similar scale of the nanoscale of the virus, so that we can take advantage of delivering gene or sensing activity inside of the cell. So we can learn a lot from the enemy, our enemy. We are really dealing with this coronavirus, but we have to be more wise. So while we are dealing with this, we can learn lesson from these small guys, right? This tiny small guy impact whole world. So your existence, whether you are small or big, but you can make huge impact. So we can learn from coronavirus, but we are taking advantage of the plant virus to use as a sensor or gene delivery system.
Great, thank you. There are a lot of questions coming in now.
Yeah.
I'm just choosing the ones that might be more technical, and then we'll go shift to maybe more of the career-related questions. From Jesse, he says, thank you for the presentation. Exactly how will your research help with the coronavirus right now? I think you touched upon that a little bit.
Well, definitely, as you can see, our ultra-fast photonic PCR, unfortunately, it's not commercially available. So I was really kind of disappointed that we should be ready, but this is relevant to coronavirus detection. So that imagine that if you have this chip that I show you at home, and then you can detect using your cellular phone all this. Then you can get all the idea, so you don't have to worry about. So at this moment, unfortunately, because of there's one lady who made a false premise, the whole field of this home diagnostic was not realized. But however, it's time to revisit and finish well. So basically, we've been working on this last 20 years, not necessarily for this coronavirus, but many virus attack can happen even the next year, even a few years later. But it's time to really prepare home diagnostic with a more sensitive and more faster detection at home than, basically than even hospital.
Great. We have another question from Hannah Jo. Thank you, Professor Lee. I'm really interested in tissue culture research. Can you explain the process of growing human or animal cells in vitro?
Okay, so due to the time, I just briefly mentioned about mini brain. This mini brain formation on chip allow us to form uniform size of the mini brain, roughly, let's say 500 micron diameter to 300 micron diameter. So this system will definitely benefit for personalized medicine. So you can take advantage of both this microfabrication and microfluidic technology to make very useful high throughput system that allow to screen thousands of the compound or thousands of different infection, virus and pathogens to make sure that what is the best way to avoid or best way to fight back.
Great. Just related to doing all these scans, Joanna Chang asks, for the chip, the IMDX, how are you going to scan the blood on the, how are you going to scan blood on cell phones? Will it be through apps, a scanning app? And how can it detect the problems through a device?
Okay, maybe I should show the slide again. Let me see. It's easy to explain. Let me share screen back. For example, in this case, you drop the blood and then you can separate plasma. And then each well is a plasma with the all DNA or RNA, so you can amplify. And then each dot will generate fluorescence color. So you can take a picture of this. So you know location of the coronavirus or SARS or MERS. So you can basically pattern all different probe so that you can identify what kind of the infection we have by patterned probe, pre-patterned probe, because all the plasma will go each chamber. I hope I answer your question.
I'll just make a reminder, if you would like to ask a question verbally, you can click on the raise hand icon and the Zoom moderator will bring you into the session to ask your question orally. I guess this was at the earlier part, but some people forgot, what does the acronym SANS stand for again?
Oops. Hello?
Oh, yes.
Okay.
Dr. Lee, can you hear?
Yeah, I can hear you.
Okay, so Samuel asks, what does the acronym SANS stand for again?
Oh, speedy, analytical, N stands for nano-optofluidic, and D is a diagnostic.
Okay. There's maybe a few more of the technical questions. There are a lot of actually career questions, and really good to see that. Halen Kim asks, what about microbrains? Are they made of human cells or bacteria? What are they made of?
No, it's made out of the human cell or animal cell. It depends on study what you like to do. But preferably, human cell is best. So I don't know how many people know about IPS, induced pluripotent stem cell. So you can use your skin cell to reprogram and then make a mini brain. So it's basically it's a human cell, and then you can do reprogramming of the skin cell to make different organs.
Okay. I also know that you had the chips on there where there was a vacuum. So another participant is asking, Skylar Rue is asking, how does the vacuum actually work?
Actually, let me see. Let me show you. Can you see? I'm sharing again.
No, we don't see it just yet. Now we see it, yes.
Okay, so you can see there's no external pump, right? So this vacuum battery means it's like your lung. We store already negative pressure. So you build up this negative pressure because of the material itself has a many porosity. At this, by looking at the eyes, there, you cannot see this porosity. It's a nanoscale porous structure that are allowed to store negative pressure. And then when we pack this device, and when we open this device, we have about 20 minutes to operate because there's a slow the pressure buildup. So basically, this material is sucking all the solution. So it's not really electrical battery, it's a mechanical battery. It's a negative energy. We are storing energy inside, and when we open, we can use it. The purpose of this is to make sure that anybody can use it even at home where there's no pump.
Related to that, I think there were two questions about when it will be publicly available. So Andrew Kim asked, what is your predicted timeline till this process becomes widely used? And Evelyn also asked, how long do you think it'll take for the smart sands technology to be used globally?
Because of this coronavirus, it motivates me to speed up. Actually, technology is ready, university level research is ready. I mean, but the problem is manufacturing. So do not underestimate the power of the manufacturing science. Somehow we are in United States and everybody think that we shouldn't do manufacturing in the United States, everything should go to the different country. This is a big mistake that the United States made. We have to balance. We cannot rely on all other people's, but we developed this technology, but if other people cannot manufacture, this is useless technology that you develop. So we have to have a nice balance that we have to develop manufacturing capability in the United States or any other place, but you need to have both researcher who can do fundamental research as well as applied research together so that they can communicate. So hopefully, I'm looking for a right group. So hopefully within a few years, hopefully you can get to these real practical things. Yeah, but we can, you know, make more advancements, making sure that this is much cheaper, cheaper than testing at like in hospital. Right now, you cannot do PCR test unless you have to pay, unless you pay a couple $100. But I want this chip to be less than like $2. So this is, I'm hoping in few years, I'm hoping, yeah. So I have to find the right, like a philanthropist or a businessman who can really work together. So I'm working on it.
Excellent. We look forward to it. Maybe shifting a little bit of gears, it seems like there's a lot of people interested with the question that Eugene Cho posted, asking when or how did you know that you wanted to pursue this kind of work?
That's a good question. I was in the industry, so at the time I was doing completely different work. Industry, I was in defense electronic company. So this defense electronic company, I was working on, you know, laser that can shoot the missile, or developing electronic chip that is the most reliable electronic chip for military purpose. But then I realized that I want to do something different. So I went back to school. So I went back to graduate school age of 36. So that's the point where I decided to work on medical device. So last 20 years, I've been working on this kind of medical device. So it's not that I decided to do that when I was in high school. At the time, I didn't have any idea.
Actually, that's a good segue for the next most popular question. Jiwoo Kang asks, what do you recommend for ways to get more involved in bioengineering during high school?
I guess in high school, it's not easy to find a lab to work with. If you can, in local university, you can go to a lab, some university lab, or even company for interns. Then you can pick up many different skills. The basic skill, just like PCR or ELISA, or even for cell culture, that will help to really understand how to handle many different tissue engineering or medical device. I know that one of my PhD student who worked in local college when he was in high school after his class. So that will help. But if you don't have that kind of environment, you can start working at some lab when you go to college.
I see. Yeah, actually, it seems like another follow-up question that's related to that is, do you have high school students working in your lab? And if yes, what kind of work can they do? Or what level of work are they able to do?
Yeah, as a matter of fact, I'm hosting 2 students this summer, but at Berkeley, I used to have many, but now I'm Harvard, this is a new lab, so we need to set up first, so I cannot really invite many people, but I like to, I'm hosting intentionally high school student, so that they can pick up many different skill their own during the summertime. But at this summer, it will be quite hectic because we don't know when we will open this lab. But in general, yes, we host a few high school students.
Yeah, from my personal experience, it just seems like students are starting to do research earlier and earlier. And I feel like even if it's just simple things like just assisting or cleaning or just doing data entry or something simple, it gets your foot in the door. And then the next year, you can do more and more complicated things.
Yeah, I agree with the band. Don't expect that you learn, fancy design first. If you don't understand how to deal with the pipette, or even as Ben mentioned, cleaning. When I really learned the experimental lab skill, I washed the dish. So it is important. Or sometimes I clean all the mess of all tissue culture room. So you have to learn very, very, very basic things at the beginning. And if you are faithful to handle washing or cleaning, people trust you, because dealing with the cell is like taking care of like a babysitting. So the senior students or PhD student will not trust you if you don't show that you are really, really responsible person, no matter what they ask, even simple, dishwashing.
I had an internship at a tech company my sophomore year, and I didn't know any computer engineering, but I had to run these benchmark tests. I just sat there, clicked the button to start the test, and I waited 20 minutes. I wrote down a number, and so it was sort of repetitive, but it turned out that the department needed those numbers to compare against their prior chips. So it turned out to be as important, but yeah, I can understand that you kind of start simple.
That's right.
Samuel asks, what are some different jobs in bioengineering?
As you can see, you can be a device engineer, so that you can develop not only molecular diagnostic chip or wearable sensors or real equipment like MRI or PET. There are many medical equipment that you have to deal with as an engineer. But then actually there are many people who are working on so-called tissue engineering. So they are developing like organ on a chip or organoid, or making real the tissue to be used in real, during the surgery time, so that many people working on tissue engineering, or some people are working on so-called drug delivery. So they are working on new device, small scale device, nanoscale device to pack the drug or gene, so that you can basically make an effective gene delivery or drug delivery, because we have to think about what is the best way to deliver the drug through the BBB in the brain. So there are many people who are good at chemistry. They tend to do more gene delivery or drug delivery. More physics-oriented bioengineer working on device. So you can enjoy your different background, but contribute to bioengineering for many different area. Or some people are interested in mathematics, so they work on biostatistics or simulation. They work on many different model. So there are a wide range of the biomedical engineers in the field. So either you can work industry, or you can work in research institute, or you can become the professor like myself. So many different jobs you can find.
Great, thank you. We have a brave soul who is willing to ask a question verbally. So David Kim, if you'd like to unmute, you may ask the next question for Professor Lee.
Hello, can you hear me?
Yes.
Oh, okay. So my question was like, how would the government be involved in the at-home tests, and would they be able to get the information from it?
Well, this is not done yet, so we have to make sure that this kind of the device is robust and reliable. So unfortunately, that is another important issue. But if you worry about the security, which is important question, nothing can be done. Right now, your information, it's nothing to do with medical information, but can be tapped out, right? It depends on how we use it. Money itself is not evil. It depends on how you use it. So our medical information will be very useful, but if some third party is taking advantage of it, yes, government should really make the policy to punish those people who misuse it. So there are many, your personal information, moment, not medical information, can be misused. So instead of worrying about, what about our molecular information? Yes, if it's misused, it's really dangerous. But however, if we use it properly, it can be very useful information to inform that, for example, I have a coronavirus, then I can stay home, and then people can really help to monitor each other, and so you can use it more constructively.
Great, thank you. Thank you, David. I guess since we switched a little bit on the technical side, there are a few more questions that are more technical in nature. Hai-Lin Kim asks, how do you control where you want the viruses to deliver DNA?
Virus to deliver DNA. How do you? I'm not sure why we want to deliver virus to the DNA.
Okay.
Well, anyway, if she's asking how I mean, if it is like a plant virus that we made for the sensor purpose, is we're using the same plant virus, but we decorate it with a gold to make sensor. we deliver this inside of the cell. It's not DNA. We deliver inside of the cell by endocytosis, or we deliver this plant virus by inside of cell. If you want to use it as a gene delivery system, we attach the gene in the surface or inside, so we can liberate them from outside by using the light. You resonate the surface of this so-called plasmonic, which is nothing but metal surface. So the metal surface has electrons. So from outside, you can say hello. Basically, you use a light wave. Light is electromagnetic wave, and you oscillate. You resonate with the electron on the surface of the this so-called, we call optical antenna, but it's made out of plant virus. So we can oscillate electron in the surface. Basically, if you use a good word, you can resonate your friend. So this wave, electromagnetic wave, can resonate electron on the surface of the plant virus so that we can send the signal to release DNA. It's like a cellular phone. I hope I explained to you, but if you don't understand, it's okay. Just remember specific wavelengths of the light, which is electromagnetic field, can resonate electron of surface. Electron is in metal surface. You can oscillate. When these wavelengths match with together, you can make a local heating. So if you attach the DNA or RNA or peptide, you can detach due to the resonance matching. But it's inside of the cell, not to the DNA. I guess she's right. In a way, we want to deliver this inside of the cell, and the released RNA or DNA is interacting with the DNA. Okay, so now I understand better. She was right. Okay, so yeah.
Sure. We'll just remind everyone again, please click the raise hand button on the bottom of your screen to ask questions orally, and your question will be answered immediately. So,
somehow line is disconnected.
Oh no. Dr. Lee, can you hear us? Okay.
Oh, okay.
Yep, okay. The next question is from Nayun Ko. Thank you for the presentation, Dr. Lee. What motivated you to study medicine? And perhaps I know your degree, your PhD was in applied physics and bioengineering, but I know we offline had spoken about, studying something and then working in a different area. Could you explain maybe your path through the different majors and fields and maybe how you ended up in the School of Medicine?
Okay. Yes, it's an interesting journey. I study biophysics as an undergraduate student, but then I worked in industry as I mentioned, defense electronic company. So the combination of the engineering and biophysics motivate me to think about what is more practical things to do. So it's automatically a medical field. Yes, I can study fundamental understanding of only one protein to death, but I decide to work on more practical device. But the fundamental study has to be done always if you want to develop new device. For example, let's say ultra-fast photonic PCR, you have to really understand quantum mechanics later that you study in physics. But then if you don't understand, you cannot really develop this PCR to make less than 1 minute instead of 1 hour. So you need to have a both understanding of physics and biology. It comes naturally that if you want to help others, this medical field is kind of obvious choice. But you can choose many different fields. But the reason I choose the medical field is just my personal preference to work on practical biomedical devices.
Excellent. There's actually a related question. E-Core asks, is someone majoring in computer science able to work with the medical professionals to do research in life sciences and create new innovations? I guess this is
Yes,
maybe a
absolutely.
collaboration with the medical and the technical engineering.
Today, I didn't show example with the collaborating computer science scientists. Definitely, for example, if we have thousands of different biomarker of the DNA we detect, then we have to think about how to work with the computer scientist to sort it out, the data. If we accumulate huge data, because at this moment we are relying on few biomarkers to identify what kind of cancer we have, what kind of infectious disease we have. It's only a few biomarkers, it's limited, but if we advance this chip to make 1,000 by 1,000 array, each well we have a PCR reaction, but it's a different probe. Also, you can have also different probe for different food and also different environmental factor. So all information can be accumulated, and someone has to recognize what kind of signal is generating more when we have a certain behavior. So AI definitely be useful to recognize this huge data. At this moment, as I mentioned, all the PCR is very limited data, only few data. But you can imagine using this kind of chip, you can have 1,000 by 1,000 array of different biomarker that can recognize the pattern of the all different signal intensity increase depends on virus attack or emotional attack. As you can identify this. So there are many possible collaboration with the computer scientist.
I see. And I also know the advent of AI, machine learning, that has also spread to other fields as well. So
That's right.
seems like a hot topic. The nature of this web chat is that we're kind of shifting gears, but it seems like a lot of people are interested in if were there any difficulties you faced in your career as a Korean American?
That's a good question. I came here after second year of high school. So at the time, it's already 44 years ago. Yeah, it was very challenging because my language, but other than that, nothing special, but I want to encourage you, if you feel that you have some disadvantage because of you are Korean American, you have to think that wherever you stand, this is your land. Okay, doesn't matter where you have citizenship, but if you stand in America, you can say, okay, this is my land, and then you have to claim that you have ownership. So you have to think differently, so that you have to always deal with many different situations. It doesn't matter whether you are Caucasian or African American. You have to stand firm as a citizen. Now is a more global period, so you have to think about as a citizen who, and then you have a responsibility to take care of many global issue. So don't feel bad that you are limited because of your Korean America. Yes, some time to time, I sense that it's some maybe injustice, but it can happen even in Korea if you stay in Korea. Okay, so there are many injustices regardless of this ethnic group, or it's more related with actually personality that you have to handle. So don't think that Korean American has some disadvantage. Even though someone ridicule you during this season, don't feel bad. When I came to United States, a lot of little kid was, tease me with the eyes, said like ching ching ching. It's gone, but now I heard that recently many people get, hurt feeling with this coronavirus. But I want to encourage you that you are the owner of this place if you stay here.
Well, thank you for that really nice message. I also feel like with KC, having this opportunity to speak with Korean American role models who have gone through their career and become successful is really valuable to be able to say, oh, that's an endpoint, I can get there too. So I guess I would also encourage a lot of the students to attend some of these events where you do have Asian Americans or Korean Americans speaking. So I think that also helps
really
kind of looking
encourage
forward.
you that no matter where you are, and sometimes, you know, let's say if you were born and raised or you came to the United States when you're in high school or junior high school, doesn't matter. I want to make sure that, you know, you need to really speak out, not with pride. You know, pride can kill yourself. So you have to always humbly think about others first. If you think about others first, uh, even though they might say something negative, you can overcome. But if you try to fight back because you want to claim that, you know, it is my right to fight. Actually, fighting is not the best way. You have to think about why he's or she's talking back to me with a negative feeling that I have to deal with. But most important thing is humble attitude that you are creator. If you believe God, you have to believe that you are created by God. If you don't believe God, you have to remember you have to be creative because you are God. I hope you understand that. Either whether you believe or not, you have to remember you are creative, right? Then you have to think about how to handle situation. If you are creative, you have to think about how to deal with many different people instead of fighting back all the time. You know, many people said, oh, if you have ownership, you have to fight back. I used to think like that, but then actually it really kills, you know, both mind, because you actually, your worst enemy is your own pride.
Great, thank you. Good, great advice. I guess one interesting question here is Yujong Choi asked, during the presentation, you said you were inspired by pieces of art. And do you think such artistic talents are useful for bioengineering? This maybe touches upon different fields emerging.
Definitely, as you can see, all the new device that we develop, I always think about what's the best way to interface with people, user-friendly system. You can learn lesson from Apple. Why Apple? People like Apple, it's because it's nice design. So it's artistic design. So you have to take advantage if you have an artistic design. But not all bioengineer has artistic design. I mean, the talent. It's okay. But if you have it, it's your own benefit. But if you don't have it, at least you can appreciate, and then you can learn from you know many different artists or designer to think about user-friendly system, because we have to make something for people.
That's right. So sort of related question is, Edwin asked, what college would be good for this study? And Jesse also asked, what subjects will serve as prerequisites for this kind of study? And so I suppose maybe the college would be their engineering colleges, or they're more well-rounded arts and science colleges. Are there any types of colleges to get into this field that would be more appropriate, or are there not?
I would like to suggest you don't have to major bioengineering. So for example, I studied biophysics, but before I finished my degree, I studied electrical engineering and molecular cell biology. So you don't have to really major bioengineering. Yes, there are many university has the bioengineering department, but I like to encourage you to study physics or chemistry or biology or electrical engineering. you don't have to study bioengineering, but you can learn biology by doing it. That's the best way. The biology, you have to do it. You have to feel it. You start with a very basic dishwashing or uh, babysitting cell culture and so on. So of course you can do bioengineering, but you don't have to major bioengineering to be bioengineer. As you noticed in my degree is not all necessarily bioengineering, right? So please remember, you can study even design, but you can change it later that, okay, if you want to do bioengineering, you can study basic molecular cell biology and some engineering class. So you can go to any college. You don't have to go to also top school. Actually, I want to encourage you that you can go many different schools, especially in the United States, at local, state university or local college. In terms of the knowledge, there's no difference. Okay, I can share with you. People think that, oh, because you're Harvard, but I was in a public university. UC Berkeley is public university. There's a huge difference between public university and private university. I don't see any difference in terms of the education. Of course, in private school, they tend to babysit, so they ask students to drop if they don't get a good grade. So in public university, they don't do that, but don't afraid to go to public university, because you become more stronger because you have to take care of yourself. Professors at public university wouldn't say that, please drop this class because you're gonna get bad grade. But in private school, you have some luxury, but for me, doesn't matter which university you go, most important thing is your attitude to study in depth. That's most important.
Excellent. I guess also then related to prepare, a lot of questions related to what high school students can do. Athena Choi asks, what advice would you give high school students who are interested in science and research and medicine? And related, Isu Kim asks, how early did you prepare for a field in the STEM industry?
I would recommend, if you're interested in this kind of field, most important thing is physics, chemistry, biology. It's a basic science. And then if you are good at math, it helps to model and simulate. So it's a basic STEM is most important things. You don't have to learn biotechnology while in high school. If you have the time, you can learn. That's the benefit, your advantage. But don't feel bad that, oh, I didn't learn how to deal with a PCR. It's okay. You don't need to learn right away. But I want you to learn basic physics and chemistry and biology. That's most important, the fundamental.
I guess related to, in terms of your development into in studying all this, was there a difficult challenge, one of the most difficult challenges in your studies, either in college or through a PhD?
Absolutely. As I share with you, I came here second year of high school, so it was very difficult in terms of language. But I guess nowadays, most of the Korean American who was born and raised, or who came to later stage, speaking English much better than my generation. So you shouldn't worry about this English part. But in terms of dealing with many different culture or even class, there are many unexpected challenge. Let's say if personally you want to go to certain school but it didn't make it, so you get disappointed. But how I realized that there is one school that I really wanted to go, but I didn't make it. Okay, for the undergraduate. So I was always disappointed. But then I realized that when I get offer as a professor, I realized, why did I really struggle with this? So I want to encourage you that if you didn't make the school that you like to go, that's not end of your life. So don't feel bad. So those kind of like complex bother you once in a while, but don't bother with this. Or let's say you want to go to, let's say graduate school, but didn't happen because whatever reason, I have to work. But then those kind of things is not really minus, because while I was in the industry, I learned a lot of the things that I didn't learn from school. So it benefit when I went back to graduate school at age of 36. So it really helped me to speed up and then become professor before I finish PhD. So it's possible that if you learn as a, let's say, auto mechanic, you become best. And you'll be surprised if you really understand fundamental of the car, and you can become even physicist if you really understand. Okay, so please be faithful to whatever you do, even though you are working on Burger King or hamburger shop or as a janitor. Doesn't matter. Actually, I was when I came to United States, my first job was boss boy because I couldn't speak English. And you do best at what you do, and then I have to work two jobs. Boss boy 5 p.m. to 2 a.m. But then weekend I was dishwasher for Chinese restaurant. So it doesn't matter what kind of job you deal with, you become the best in your work, and then you kind of build up your foundation of work ethic as well as your attitude, so that you can utilize your experience, even though it's a science or engineering. You'll be surprised all your previous background will be used at the end.
Great, thank you. That's very inspiring words. I guess maybe we will end the Q&A session now. Professor Lee, thank you so much for your inspiring talk and all the Q&A, and just touching upon different topics of how to help high school students and also the cutting edge research that you're working on. We'd like to give you a round of applause. Everyone always is typing thank you here. Would you be able to just share a few last words before we end the session then?
Yeah, actually, I like to really share with you the verse that I enjoy to read today, which is maybe relevant to today's session, that the four things on the earth are small, yet they are extremely wise. You are at this moment small, but think about yourself. So this sentence saying that there are ants are creature of the little strength, yet they store up their food in the summer. Okay, Connies are creature of the little power, yet they make their home in the cracks. Locusts have no king, yet they advance together in ranks. A lizard can be caught with hand, yet it is found in king's palace. So I hope you can really think about these four amazing, wise little, things that you can remember. And it doesn't matter whether you are dealing with a difficulty or you face with the difficulty, it will happen always, even college or even after college. But I want to encourage you to remember that you are a creative person, and then think about how to overcome. Regardless whether you believe God who created with his image, or even though you don't believe God, it's okay. But then you, at this moment, hopefully you can realize that what is most important things to remember as a person who doesn't believe God, but yet you have to be creative because you are God if you don't believe God. I hope you can remember the most important thing, that you are a creative person.
Great. Thank you so much, Professor Lee, for those kind words. We will, please don't leave yet. So we will do the evaluation Zoom poll, and it'll just take 30 seconds. If you could just provide us some feedback. There should be a poll that will be popping up. So you may go ahead and click on that. And while we're doing that, just take a few seconds, and I will just in a few moments just share the next science concert session that we'll be having. So as you're filling out the poll, I'll explain that next Tuesday is our third science concert, which will be on May 5th on Tuesday at 6 p.m. Eastern Time, and that will be Dr. Daniel Lee, who is a professor of electrical and computer engineering at Cornell Tech in New York. And the general topic that he will be speaking upon will be artificial intelligence and robotics. So we look forward to having you join us again on next Tuesday as well. So that concludes our session here. Thank you again, Professor Lee. It was really enjoyable. And thank you for all the attendees who joined. We hope you enjoyed the session, and we hope to see you again very shortly. Thank you.
Thank you. Bye.
Bye-bye.